Now it's your turn to graph a linear equation by finding the x-intercept, y-intercept, and one checkpoint. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In this problem, we're asked to graph the linear equation x minus 3y equals negative 6 by finding the x-intercept, y-intercept, and one checkpoint. So to start, we'll find the x-intercept. And the x-intercept is going to occur where y equals 0, as it's the place where we intersect our y-axis. So to algebraically find that, I'll replace y equals 0 in the equation x minus 3y equals negative 6 and solve for x. So I have x minus 3 times 0 equals negative 6. And that'll simplify then to x minus 0 equals negative 6, which is of course x equals negative 6. So the point that I'm going to graph is the point negative 6, 0. Next I'll find the y-intercept. And the y-intercept is going to occur where x equals 0, as it's the place where my equation intersects the y-axis. So to algebraically find that, I'll replace x with 0 and solve for y. So with that equation x minus 3y equals negative 6, replacing x with 0, I'll get 0 minus 3y equal to negative 6. Simplifying that, I'll get negative 3y equals negative 6, and dividing each side by negative 3, I'm going to get y equals 2. That'll mean that my graph contains the point 0, positive 2. Now, at this point, I still need to find my checkpoint, but I'm going to scale and label my axes and plot these 2 points so that my checkpoint is one that helps me draw the rest of this graph. Again, 2 points are enough to graph a linear equation, but this third checkpoint is going to, 1, help us check to see if we made any arithmetic mistakes, and 2, help us make sure that our graph is accurate. 2 are enough, but it's possible with just 2 that I might skew my ruler in one way and not draw a very accurate graph. So that third point will help avoid both of those things. So coming over to my graph, I'm going to scale and label the x and y axis, and I need to be able to fit the point negative 6, 0 and 0, 2 on here. So with this 10 by 10 grid, I'm just going to scale these axes with each unit representing 1 tick mark. So I'll label off 5 and 10 on the x and y axis, and then negative 5 and negative 10. Okay, and now plotting these 2 points, I have negative 6, 0, so I'll put that on my graph, and 0, 2. I'll plot that one as well. Now that I have these 2 points, I can see that it'd be helpful to have a positive x value, a point with a positive x value also graphed. So again, I can choose any x or y value that I want for my checkpoint. I'm going to pick positive 6 for x, and I'm choosing that because I see that I have a value of negative 6 for x graphed, a value of 0 for x graphed, and so I'm going to choose positive 6 to give me a point in that first quadrant. So to determine the y value that's associated with this point, I will replace x with 6 in my original equation. So I have x minus 3y equals negative 6. So replacing x with 6, I'll have 6 minus 3y equal to negative 6. And simplifying that, I will subtract 6 from each side, giving me negative 3y equal to negative 12. And dividing each side by negative 3, I'm going to get y equals 4. So my point, I've chosen to have an x value of 6, and I've determined that its associated y value is 4. So it's the point 6, 4. Coming over to my graph, I'll plot that point 6, 4. So I'll go to where x is 6 and y is 4, and plot that point. And now I'm ready to connect these 3 points. I'll use my ruler and I'll graph that full equation representing all solutions to the linear equation x minus 3y equals negative 6. So I'll bring my ruler up and I'll make sure that it goes through these 3 points. And now that I have it lined up through all 3, I'll draw that line. And then I'll put arrows on each side to show that this line continues indefinitely. And I'll label it with its equation. So that was x minus 3y equals negative 6.